So we are kind of expanding trig functions from right angle trigonometry to move into putting them on the coordinate plane, which then moves us into the unit circle. All right. And so you start putting these things on the coordinate plane, and this is not unit. All right. So when it's just any point on the coordinate plane, it does not mean that you are 1 unit away from the center of the coordinate plane, 0, 0, the origin. These are any points as far away as you want to be, right? But any point on the coordinate plane, you can create a right triangle, right? And so they have picked some point P, this right here, with the coordinates X and Y. And anytime you do this, they just draw a straight line down. The height of that is your Y. And then across, how far you are to the right or left, is your X. And you create a right triangle. If you don't know what your R is, then you can use Pythagorean theorem. X squared plus Y squared equals R squared. So the square root of X squared plus Y squared is going to be your R, right? And then all of a sudden you have the same ratios that you would have had in a right triangle. And so your sine now is your Y value, because we're always talking about this angle down here. So opposite is going to be your Y value over R. Adjacent then is your X value over R, and your tangent is opposite Y over adjacent X, okay? And then your reciprocal functions are the same. Cosecants R over Y, secants R over X, and cotangents X over Y. And so you can use these really for any one in the coordinate plane. You do have to think about what quadrant you're in. So when you start getting to these, here's one of them, give me the other ones, then you do have to think about what quadrant you're in. So you do have to keep in mind that your sine and cosine will be positive here because your X and Y are positive. Your tangent and cotangent, secant and cosecant will all be positive. So everything's going to be positive here because you basically have all positive numbers, all right? Your R is really always going to be positive because it's the square root of 2 numbers squared, and we're going to always consider the positive root. But then when we move into this quadrant, my X's are now negative. So that's going to negate my cosine. That's going to negate my secant. That's also going to negate my tangent and my cotangent because I'm going to have 1 positive over 1 negative, right? When I move down here to my third quadrant, that's going to affect my sine, my cosine, my secant, and my cosecant. But now my tangent's actually going to be positive and my cotangent's going to be positive because I'm going to have a negative X over a negative Y and vice versa, right? And then over here, my X is positive, but my Y is negative. And so my cosine and my secant will both be positive. My sine and my cosecant will be negative. And my tangents and cotangents will be negative in this quadrant as well. And so you do have to start thinking about where you are and how that affects your positives and negatives. But other than that, you are literally doing right angle trigonometry here. All right, so let's look at the example. State the 6 trigonometric functions of an angle in standard position if its terminal side passes through the point -6, -8. So I am in third quadrant here. I do need to solve for my R. I know my X. I know my Y. My R is going to be the square root of X squared plus Y squared. So that's the square root of 100. So my R is going to be 10. Now I just fill them in. I mean, literally just fill them in. My sine is going to be Y over R. And of course, you do want to reduce them. Cosine, X over R. Tangent is Y over X. And then you just flip them, right? To do the other ones, that's pretty straightforward. All right, any questions on these? When you end up on a quadrant, you end up with either a straight angle, right, like 180, or you end up with some variable, like if you're 90 degrees, 270, those are all basically multiples of 90, no matter where you end up on, right? And so your R becomes a little bit different. your values here change because you have this thing that happens with a 90-degree angle. So these are special angles. And we do actually look at these when we're talking about the unit circle. When we get to unit circle, we're actually going to talk about these as well. But you actually have trigonometric functions here, and then some of them become undefined because then you start having zeros, issues like that. So if I look at the point 0, 1, all of a sudden my radius is also 1, right? So if my x and y are 0 and 1, again, r is x squared plus y squared, right? Which is going to give us 1 there. And so now I'm going to have some issues when I get to anything that has a denominator problem. So if I look at my sine is not an issue. That's just going to be my y value over my x value, or over my r value. My cosine is actually not a problem either. Right? But then I have a problem when I start reciprocating these, all right? And when I get to tangent, right? Tangent is going to be y over x. What's my problem here? What's my problem? Denominator is 0. So you actually can have trig functions that are undefined. If you were to put into your calculator the tangent of 270, you're going to get an error. It is undefined as long as you are in degrees, assuming you're in degrees, right? So you have to consider the fact that you could have undefined functions when you start looking at unit circle, and when you start looking at anywhere on the, if you end up having something like a 0 as one of your coordinates. When you have a 0 as one of your coordinates, it's going to cause issues when that coordinate becomes the denominator. Okay, and so there are going to be situations where you have undefined as one of your functions, and actually undefined will be 2 of your functions. It'll work at tangent and at secant. You're going to have a problem for this particular one. All right, and so that's something you have to keep in mind when you're doing these. All right, so we have some special angles that we've already talked about. We've talked about 30, 45, and 60. Like I said, you need to have the sine, cosine, and tangent memorized for those 3. And you will before this is all over, because it's going to be repetitive when we do the next part. But when you start looking at it, why does this work? Why does it matter that you need to know those 3? Because if you look at this 120 degrees takes me to this point here, right? But from here down, I have 60 degrees. And so you should start seeing like this same angle is going to have this 60 and this 120 is going to have the same opposite, adjacent, and radius, right? And so 60 and 120 are going to have the same exact sine, cosine, and tangent. The only difference is your positives and negatives. Because 60 is going to drop you off here. 120 is going to drop you off here. So they drop you off in different quadrants. But when you start doing opposite over adjacent, the absolute value of those are going to be the same. And so if you know those 3 special angles, then you're going to know the reference angle. And by reference angle, I mean the closest angle to the x-axis, okay? So like for this, my reference angle is 180 minus this angle is going to be 60. For this guy, he goes past it, 225. But the closest x-axis is this one. So I'm going to say 225 minus the 180. If you go past it, subtract the 180 from it. If you're before it, do 180 minus the angle. This one's going to be 45. For this one, he went all the way around to 330. The closest x-axis is this guy, which is 360 if I kept going. So I'm going to say 360 minus 330. Reference angle is 30. This one actually looped. Do you see that? 420 went all the way around to 360 and kept going. It went past the 360. So I'm going to say 420 minus 360. My reference angle is 60. And so you are looking at the closest angle to the x-axis. If you stop ahead of it, subtract the closest x-axis from it. If you go past it, take your angle and subtract the x-axis. So depending on which way you drop is how you're going to subtract those, okay? Or you could always do absolute value. It doesn't matter because your reference angle is always positive. So for this one, we are anywhere on the coordinate plane. They said the cosine of theta is negative 2/3. The cosine of theta is negative 2/3. Cosine is your x over your r, right? So cosine of theta is x over r. If the cosine is negative, I have to be in one of two quadrants, right? So if my cosine is negative, I am either going to be here or here, right? That's the only way I can have a negative cosine. Does that make sense? Because my negative is directed by that x, and my x is negative in the second and third quadrant. They always give you a second piece of information here, okay? The second piece of information they gave you is that your sign is what? Positive or negative? Positive. That's my y value. My sign is positive in two of these, first and second, all right? The only place that met both of those is in the second quadrant. Does that make sense? So I know that I am in the second quadrant. That is important because that's going to determine what my values are when I get to the end of this. So I know that I am in the second quadrant. I have a negative cosine and a positive sine. That happens in the second quadrant. So you're going to use those two pieces of information first to figure out what quadrant you're in. And then it wants me to find the tangent and the cosecant. They have given me my x and r. I really need my y to know my tangent. I also need my y to know my cosecant because that's the reciprocal of my sine, okay? So I am going to use these numbers here to find my y value. Remember that my r equals the square root of x squared plus y squared. Fill in what you know, solve for what you don't know. I know my r. My r is the denominator, that is 3. I know my x. My x is my numerator there, negative 2. Negative 2 squared plus y squared. How do I solve this guy? How do I get rid of my radical? Square both sides. So 9 equals 4 plus y squared, right? Subtract your 4. Y squared equals 5. So y equals the positive or negative root of 5. I am in which quadrant? The second quadrant. Is my y the positive square root or the negative square root? The positive. So my y here is positive square root of 5. Now I can solve for any trig function they ask for, right? The two functions that they asked for were tangent. They wanted tangent of theta. Tangent of theta is y over x. I know my y value. I know my x value. They also asked for cosecant. Cosecant is the reciprocal of what? Sine, which is r over y. I know my r. I know my y. I need to rationalize it. 3 square root of 5 over 5. All right. So given something like this, you can find it if it's anywhere on the coordinate plane. You just need to first figure out what quadrant you're in. Use Pythagorean theorem basically to solve for your missing variable. And then whatever they're asking for, plug it in. So go ahead and try it. The unit circle is a circle centered at the origin and having a radius of 1 unit. That's why it's called the unit circle, because the radius is 1 unit, okay? What this does when your radius becomes 1 is that you no longer have to worry about the ratio as much. because it's just y over 1, x over 1. And so then all of a sudden, your sine on the unit circle is just your y coordinate of wherever the terminal point is for that angle. Your cosine is just your x coordinate of wherever the terminal side is. Your tangent is your y over x, assuming that you're not at one of your points where x equals 0. Your cosecant is 1 over y, same assumption. For y, secant is 1 over x, cotangent x over y. And so if you're talking about on the coordinate plane, anywhere on the coordinate plane, you have to calculate your y, because you could be more than 1 unit away from the origin. But unit circle brings it all down to origin, 1 unit away from the origin, because really a 60-degree angle that ends with a radius of 1 or a 60-degree angle that ends with a radius of 12 is going to have the same ratios between its sides, okay? And so that's why we use the unit circle, because it gives us some common angles that we can very quickly figure out what the trig functions are, all right? These are all based on your common trig functions, your 3, 30, 45, and 60, and then your quadrants, your 0, your 90, your 180, your 270, your 360, okay? So we build the whole unit circle off of those. All right, it tells you how this works. If my radius is 1, I'm literally doing opposite over hypotenuse, adjacent over hypotenuse. So understand that just because we move from right angle trigonometry to unit circle trigonometry, it is all based off of right angles, okay? It is all based off of right triangles. And so it's the same process, we're just moving it into a different realm so that no longer, when you're talking about a triangle, you're not gonna have a negative degrees. That's not gonna happen in an actual triangle, right? But it will happen when you start talking about bearing or direction. And so this opens up to no longer be constrained to a triangle, but now we can talk about direction and movement as well. So it just frees you up for some more word problems that aren't constricted to a ladder leaning against a wall, right? So we build the entire unit circle off of this. That's why over and over I keep telling you to know those 3 major ones. By the way, the unit circle has degrees and radians. You can always use your conversion. Let's say you just cannot remember which one it is. Use your 180 over pi or pi over 180 if you need to convert, right? But it's built off of those 3. I've already given you one filled out, but I have blank ones that I'll be giving you. So if you want to, rewrite them so that you memorize them better. But if you look, you have a 30-degree angle. And if you just walk around it, this is 1 pi over 6, go 30 more degrees, 2 pi over 6, which reduces to pi over 3, 3 pi over 6, which reduces to 1/2, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6 reduces, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6 is also 2 pi. And so you can see that those are built off of your 30-degree angles. They walk around, okay? Then you have your 45-degree angles. These are your halfway points. Halfway between 0 and 90 is 45. The middle ones are built off of your 45. So this is 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, okay? And so that builds your unit circle. Why does that help me? Well, if I know the cosine and the sine, I know the x and the y value at those. And so on your sheet, you will see that you have an x and a y value at each point. Each terminal point for these has an x and y value, all right? And so you'll see that your terminal point here ends at the point 1, 0. Why does this help me? Well, that tells me my sine and cosine at that point, right? You'll notice that your terminal point here is square root of 3 over 2, 1/2, because the sine of a 30-degree angle is 1/2, the cosine is square root of 3 over 2. If you mirror that across, the reference angle for this guy, you'll notice it's color-coded on mine. The reference angle for all of these is 30 degrees. See these 4? They're all blue on mine. All those reference angles are 30 degrees. If you look on your sheet, they all have the same sine and cosine, square root of 3 over 2 and 1/2, right? The only difference is the positives and negatives. Positive, positive, negative, positive, negative, negative, positive, negative, right? The 45s, you'll see they're all red on mine. They're color coordinated. They all have a reference angle of 45. Whether you're at 45 or at 225, your reference angle is 45. That's why your x and y's are the same. The only thing that changes is your positives and negatives. Same thing for these guys, your pi over 3s. All of your pi over 3s are 60-degree angles of some sort. So they all have 1/2 square root of 3 over 2 as their x and y's. That's because every reference angle is the same. And so really, once you learn the first quadrant, it mirrors all the way around this guy, okay? It just mirrors. The only thing that changes is your positives and negatives, all right? This is going to help you tremendously when you start doing ones that have reference angles in them that you know, okay? So let's look at how we use it. Use the unit circle to state the exact value. When it says exact value, it means it wants the radical or the fraction. It does not want a decimal, okay? So exact value means your ratio, your fraction. Use the unit circle. Cosine of 2 pi over 3. All of my pi over 3s are reference angles of 60s, okay? Right? All of my pi over 3s are 60-degree angles. I just need to know what quadrant it's in. 2 pi over 3 is in the second quadrant, all right? The second quadrant is going to be a negative x and a positive y. Negative x and positive y. So a negative cosine, a positive sine. So I know that my cosine is going to be negative here, right? I know that because of what quadrant I'm in. I know it's going to be negative. The cosine then of a 60-degree angle is what? What's the cosine of a 60-degree angle? 1/2. So in the second quadrant, it's going to be negative 1/2. All right? Make sense? 225. This is where knowing your quadrant angles are important. All right? Your first quadrant goes from 0 to 90. Your second one's 90 to 180, 180 to 270, and 270 to 360, right? They just walk around in 90s. So 225 falls between 180 and 270. So I'm in the third quadrant here, right? Third quadrant for 225. 225 is a reference angle of 45 degrees. 45 degrees. I love 45 degrees. Give those to me all day long. So my reference angle here is 45 degrees, and I am in the third quadrant. Cosecant, that's a reciprocal of what? Sine, okay? So I know that both my x and my y value are negative in the third quadrant, so I know my answer is going to be negative. My sine and cosine are the same for every 45-degree angle. It's square root of 2 over 2. So the reciprocal is going to be 2 over the square root of 2. What do you think I probably want to do with that? Rationalize it, multiply top and bottom by the square root of 2, right? We get negative 2 square root of 2 over 2, reduce it. Negative square root of 2 is my answer there. All right, see how we're doing this? Walking around the unit circle. Tangent of pi. All right, this is one of my quadrants. All right, tangent. Tangent is what over what? It's sine over cosine, which in this value is y over x, right? Y over x. So, at pi, what's my y value? And what's my x value? So 0 over negative 1, what is my tangent of pi? 0, right? As long as my 0 is on the top, I'm okay. If 0 is on the bottom, it's undefined, right? So 0. So your unit circle, using your reference angle and your quadrant angles, you can find anything. So quickly find that one. Here's the thing. We're talking about a circle. It is a cyclic function. By that, I mean you can keep going and going and going, right? It doesn't mean it just goes from 0 to 2 pi. Clearly, this is bigger than 0 to 2 pi, okay? Some things I do want to point out, though, because negative angles sometimes cause your brain to hurt, I feel like, right? If you notice, positive and negative is just direction, right? That's really true always, right? But positive and negative is just direction. Positive moves you counterclockwise, negative moves you clockwise, okay? And so, and we're talking standard position, unit circle. I want to say that because we will get to directional, and sometimes if it's a true bearing, it starts north and just does clockwise. So just standard position on the unit circle. Positive moves you counterclockwise, negative moves you clockwise, okay? So if I go up theta, my cosine here is positive, and my sine here is positive, right? If I go down the same exact degrees or radians, my reference angles should be the same, right? What you'll notice for cosine is it's still positive. Whatever the cosine was is what the cosine is. Do you see how the cosine didn't change here? Right? So when I went positive theta, my cosine was positive. When I went negative theta, my cosine was positive. I was still on my positive side of the x. But what happened to my y value is, my y value here is positive. My y value here is actually the same number, absolute value, but it's negative. So you can actually rewrite, so let's say I have the sign of negative 29 pi over 3. That's the same thing as the negative sign of 29 pi over 3. So that first part is just, you know, those two are going to be equivalent. The sign of a negative angle is the same thing as the negative sign of the positive angle because of how it works when you move quadrants, right? So then I'm saying, well, what is 29 over 3? That's kind of important as well. So what I typically do is I think of it in terms of what's the closest thing divisible by that 3 there, okay? So I'm at 29. My closest is 27, but that's not in terms of 2 pi. I'm really trying to get a coterminal angle here is what I'm trying to do. So I'm trying to actually remove circles from that. So I want to remove as many circles as I can so that I'm within one circle, so that I'm within just one unit circle instead of multiple unit circles, right? And so I am going to try to get to my closest, however many pi's I can get rid of, right? So every 2 pi is going to be one circle. In this case, my denominator is what, 3, right? So I want to look at something that's going to be an even number when I divide it by 3. So 27 is the closest thing divisible by 3, but that doesn't give me an even number. So then I'm going to go back again. I'm going to say, well, 24 is the next number divisible by 3. So if I look at this guy, I'm going to rewrite him. Negative sign of, well, I have 24 pi over 3. And what's left over to get to this 29, that's 5 pi over 3. All right, does everybody see that? So I'm just trying to remove circles when I do this. Now, how does this help me? Well, 24 over 3 is 8 pi, right? 8 pi, which is 4 circles, right? Does everybody see that? 8 pi is 4 circles. Well, when I do a complete circle, I end up where I started. So I can ignore those completely because those are going to give me the same angle and the same reference angle and the same sine and cosine is if I just look at the 5 pi over 3. So now I'm going to look at just 5 pi over 3, okay? Well, what is the sine of 5 pi over 3? Well, that's a 60-degree angle in the fourth quadrant, right? Fourth quadrant. And so it's going to be negative 60-degree angle. So my reference angle here is 60 in the fourth quadrant. So the sine of pi over 3 is going to be the same thing as the sine of a 60-degree angle, which is square root of 3 over 2, right? But in the fourth quadrant, it is negative. And then I have to consider this negative I pulled out in front of it. Negative, negative, square root of 3 over 2. So my sine here is going to be square root of 3 over 2. All right? And so when you have a really big angle that just keeps going and keeps going and keeps going, get rid of all your circles, right? Because every circle drops you in the same place. So if you can get rid of all of your circles, just evaluate what's left over. Evaluate what's left over. The negative piece of it is just, I mean, you could do it with negatives as well. It tends to make your brain hurt when you start thinking in terms of negative.